Alright, welcome. Today we're looking at stoichiometry, which is chapter 12 in our textbook. Stoichiometry looks at the quantitative relationship between reactants and products. This is kind of what we looked at in our lab on yesterday. Quantitative, remember, is just kind of a fancy way of saying that we're looking at numbers. Remember, quantitative observations always dealt with numbers. So what we're looking at here specifically is how much reactant we have, the amount of reactant we have, and the amount of product that we can create. Stoichiometry is based off of the law of conservation of mass. Mass cannot be created nor destroyed. So if we started with 70 grams of our red substance here and 30 grams of our green substance here, we have a total of 100 grams. That means when we add up all of the stuff down here that is created, remember it's a chemical reaction, so we're going to change what the substances are from up here into something new. When we total all of this up, it also has to be 100 grams. So what that does for us is it allows us to predict how much we should be able to get. To do this, we're going to use a bunch of different ratios, and those ratios come from our chemical equation. And remember, if we look at our chemical equation, the numbers out in front, our coefficients were our mole ratios. This is what we found from our lab yesterday. The ratios that produced the most precipitate or the most product came from our balanced chemical reaction. So the ratio of moles of reactants will generate a ratio of moles of product. So for example, what this equation is actually saying is that we have 2 moles of sodium. Okay, if we looked over here, we have sodium atoms right here. So if we have 1 mole here and 1 mole here, that's 2 moles of sodium reacting with 1 mole of chlorine to produce 2 moles of sodium chloride. In order, again, to solve any stoichiometry problem that we're going to do, you have to start from a balanced chemical reaction. You cannot just simply start from a skeleton equation, because the skeleton equation, remember, violates the law of conservation of mass or matter. It would create or destroy. We can't do that. A balanced reaction, remember, is going to give you the mole ratio. So for example, the lab that we did yesterday, okay, this is the same equation. Said a solution of calcium chloride reacts with a solution of sodium carbonate to produce that solid precipitate, the stuff that was at the bottom of the test tube, and a solution of sodium chloride. So what I would like you to do is pause your video and see if you can come up with some ratios that exist in this chemical reaction. Alright, since we've done that, I'm going to go ahead and give you a few of those examples. If you look at our equation up here, again, we know we could say, well, for every 1 mole of calcium chloride, there would be 1 mole of sodium carbonate. For every 1 mole of sodium carbonate, I would generate 1 mole of calcium carbonate. And for every 1 mole of calcium chloride, we would generate 2 moles of sodium chloride. There's a whole bunch of these different ones that you could have come up with. As long as their numbers are from the equation, they're all correct. Okay, so what we're going to do now is we're going to use those equations, those numbers, to start answering or solving some problems here. So for our example problem, it says if you have 2.5 moles of sodium, how many moles of chlorine would be used up to make 2.5 moles of sodium chloride? So again, the first step in any reaction is you have to start with a balanced chemical equation. So we went ahead and balanced our equation. It takes 2 NAs, 2 moles of sodium, plus a mole of chlorine to produce 2 moles of sodium chloride. Then we want to go through and get to our problem. Well, what do we have? What's our reactant? So it's saying we have 2.5 moles of sodium. So the next thing we're going to need to do, step 2, is that we need to figure out the ratio that gets us from sodium to chlorine. That ratio comes from the equation, remember. So what it's saying is, okay, well, how do I get to chlorine? Well, this is the same thing that we've been practicing. that when we did back with moles, you have to be able to cancel out this label, which means it has to go down here on the bottom. That's why we're dividing by 2. So when I multiply by a fraction 1/2, it's the same as dividing by 2, and I go from 2.5 moles of sodium to 1.25 moles of chlorine. All of this, again, just simply comes from a chemical equation. These are just ratios. Our conversions that we're going to use, okay? Conversions, remember, allow us to go from one thing that we know to something else. So the very first step, remember, always started, number 1, was always the balanced equation. We have to have that. After we have a balanced equation, then the first thing we're going to need to do in order to do any of these problems is we had to start with moles. Notice in the last problem I gave you moles. Well, not every time you're going to be able to start with that, because no scale is going to measure in moles. They're going to start you in grams. So then what you're going to have to do is convert it to moles, which we have practiced. So if you have your yellow sheet, you can certainly go back and look over that and remember, kind of jog your memory on how to convert there. Next, that second step, just like we did in the last problem, is to convert using a ratio from our balanced equation. Last step, then we're just going to convert back to grams. Okay? So each of these, if we start in grams, is going to be a 4-step problem. You're going to start again from a balanced equation. Find your number of moles, convert to the moles using the ratio from the equation, and convert back to grams. There's a little diagram over here that kind of shows you how to do that. Remember, when we convert from grams to moles, you use your molar mass as the conversion factor. Then, to go from moles of the substance we start with to the thing we're trying to solve, you're going to use the ratio from the equation. And then last, you're going to go back from moles back to grams, again using molar mass as your conversion. You just have to understand whether you're going to divide or multiply. Okay? So what we'll do next is we'll go ahead and try one of these. So if you have a periodic table, it'd probably be a good idea to grab that. So you can pause real quick if you want to grab one of those. We're going to go ahead and work through one of these, so it would be a good idea for you to have your periodic table so you know where I'm pulling some of these numbers from. So we're going to still use the equation that said when we put sodium in chlorine gas, we make sodium chloride. Remember, we have to start with a balanced equation. So right up here, I've already given you a balanced equation. So this is step 1. Some of the ones that we're going to do, you're going to have to balance the equation first. Here, it's already balanced for you. So the question I'm asking you is how many grams, so we're trying to solve grams of sodium chloride. That's what we're looking for. Can I get, if I started with 70.9 grams of chlorine? All right. Now the reason I add that last part with if I have a lot of sodium, well, if sodium were to run out, then we'd have to calculate it based on sodium. It says I have a whole bunch, so I don't have to worry about it. I can just use my chlorine. So we've already done step 1. We've balanced our equation. Step 2, we have to convert from grams to moles. So remember the gram label we want to cancel out. So this is our molar mass. This is where I found it right off the periodic table. Sorry about that. That was the wrong molar mass. I had to go ahead and change that real quick. Again, the reason we know that that was the wrong molar mass is, remember, it was a Cl2, so I had to change from 35.45, I had to double it and go up to 70.9. So that leaves me with 1 mole of chlorine. So again, first step, remember, was their balanced equation. Then step 2, we're going to convert from grams to moles. Hopefully everybody can do that. And again, the gram label cancels, and I know that I have 1 mole of chlorine. All right, step 3, we have to figure out, all right, well, what's the ratio? The ratio is for every 1 mole of chlorine, I get 2 moles of sodium chloride. So if I multiply 1 by 2, I'm going to figure out, oh, I can make 2 moles of sodium chloride. Moles of chlorine, remember, are going to cancel, so that's going to allow me to say, oh, all right, it's 2 over 1, I'm going to multiply by 2. That's the big part with where labeling is going to become really, really important. If you don't write what you have moles of, you don't know which thing you're going to be canceling out. Last step then, step number 4, to finish this thing off, you want to convert it back to grams. All right, well, moles here and here are going to cancel, and I have 1 mole of sodium chloride, which weighs 58.44. If you're not sure where I got that from, remember 35.45 grams is 1 chlorine. We're not using 79 or 70.9 because there's no 2 down here. Sodium was 22.99 grams, and when I add them up, that's 58.44. That's where that number came from. So then our final answer, is just 58.44 grams. So again, all of our steps right here. So step 1, we're going to start from grams, divide by our molar mass to get moles of reactants. Step 2, moles of reactants, we want to go using our mole ratio to get the moles of the products. Step 3 then, from our moles of our products, we're going to multiply our molar mass to get our final mass. Okay? All right, so what I'm going to have you do is in your notebook, we want you to try an example problem. So from the balancing equations, the gray worksheet, we haven't used this one, a little one in a while, but go ahead and dig that out. What we want you to do is you're going to try number 1. And what I want you to try from number 1 is that you're going to use 50 grams of O2. All right? So the equation from number 1, remember, said nickel plus oxygen formed nickel 2 oxide. So hopefully you've already balanced that thing. What I want you to try is, okay, if I used 50 grams of O2, how much NiO can I make? Go ahead and pause the video real quick, try that problem on your own, and see what you get. Once you've paused it and solved it, come back, and I'll go ahead and give you the final answer. All right. Final answer that I came up with was 233.4 grams. If you get a number pretty close, it could just simply be a rounding thing. Remember, we're going to try to round most of our answers to just simply 1 decimal place. Okay. What I'd like you to do then, for the rest of the hours, we want you to try 2 more of these. I want you to try number 4. And we're going to say the same thing. We're going to start with 50 grams of the reactant, the NCl3, and I want you to figure out how much of the chlorine you can make. And then on the back of this worksheet, number 15, we're going to start with 50 grams of hydrochloric acid, and I want you to figure out how much of the zinc chloride you can make. Put those 2 in your notebook as practice problems. If you have any questions, feel free to come up and ask me. Otherwise, good luck. Remember to make sure you turn in your classifying assignment up front for me, please.